Good day everyone, my name is Lady Rhaine Hunther F. Cancaida and I am from grade 10 Aliguyon. The topic that was assigned to group 2 where I belong is about the theorems on angles formed by tangents, secants, and chords. Before anything else, let's first have a quick review. What is a secant line? A secant line is a straight line joining 2 points on a circle. What is tangent line? Tangent line is also a straight line that touches the circle at only one point. Now that we are all ready, I will start. The first theorem states that if two secants intersect in the exterior of the circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. So this is our example for theorem number 1. So as we can see, the two secants lying on our circle, the secant ON and the secant OA. So the given measures are the measure of arc NA, which is equal to 160 degrees, and the measure of arc LE, which is equal to 30 degrees. So now let's talk about the application of the theorem. So according to the first theorem, we can find the measure of angle NOA, which is here, by subtracting the measure of arc NA to arc LE and dividing it by 2. So what is the measure of arc NA? It's 160 degrees. And the measure of arc LE is 30 degrees. 160 minus 30 is equal to 130 divided by 2 is equal to 65. So the measure of angle NOA is equals to 65. Now, what if the missing measure is the arc NA? What are we going to do about it? So, if given is the angle NOA, which is equal to 65 degrees, and the measure of arc LE, which is equal to 30 degrees, how do we find the arc NA? So, we find the arc NA, the measure of arc NA, by 2 times the measure of angle NOA plus the measure of arc LE, which is 65 times 2 plus 30, which will be equal to 160 degrees. So another question, but what if the arc LE is the missing measure? So again, we're going to manipulate the formula, and if the given is angle NOA and the measure of arc NA, then we can find the measure of arc LE by subtracting the product of angle NOA times 2 and subtracting it by the measure of arc NA, which will be equal to 160 minus 2 times 65. So 65 times 2 is equals to 130, and 160 minus 130 will be equal to 30 degrees. Next, the second theorem tells us that if a secant and a tangent intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. So this is our example for the theorem number 2. As we can see, we can find 1 secant and 1 tangent in this example. So the secant is here, and the tangent is this. So now let's talk about the application of the theorem. So how do we find the measure of angle UKT? So we're just going to subtract the measure of RQST to RQR. And RQST is equal to 190 degrees. And the RQR is equals to 86 degrees. So 190 minus 86 is equals to 104 divided by 2, which will be equal to 52. So now the measure of angle UKT is equals to 52 degrees. And just like what we do earlier, what if the missing measure is RQR? So here is how are we going to manipulate the formula. So to find the measure of RQR, we must subtract the measure of RQST to the product of angle UKT and 2. So RQST is equal to 190 minus 2 times 52. So, MDAS rule, multiply first. So, 52 times 2 is equals to 104. Then, 190 minus 104 is equals to 86. And now, the measure of angle UR is equals to 86 degrees. The same thing if the missing measure is the RQST. So, here it is. We're just going to add the product of 2 and angle UKT to the measure of RQR. So, again, MDAS rule, 52 times 2 first, and it will be equal to 104 plus 86, and which will be equal to 190 degrees. And now the measure of RQST is equals to 90 degrees. The third theorem then states that if two tangents intersect in the exterior of the circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Now the example for theorem number 3. So as we can see, we can find two tangents here. Tangent 1, tangent 2. Then now let's talk about the application of the theorem. So how do we find the measure of angle LKU? So we're going to find the measure of angle LKU by subtracting the measure of arc LEU by the measure of arc LU. So the measure of arc LEU is equal to 296 degrees, and the measure of arc LU is equals to 64 degrees. So 296 minus 64 is 232 divided by 2, which will be equal to 116 degrees. So now the measure of angle LKU is 116 degrees. So again, just like the other two theorems, what if the missing measure is arc LU? So we're going to find the arc LU by subtracting the measure of arc LEU to the product of 2 and angle LKU. So arc LEU is equal to 296 degrees, and the measure of angle LKU is equal to 116 degrees. So 296 minus 232 is equals to 64 degrees. And then the measure of arc LU is equals to 64 degrees. So again, what are we going to do if the missing measure is arc LEU? So we're just going to add the product of angle LKU and 2 and the measure of arc LU. So the measure of angle LKU is equal to 116 degrees, and the measure of arc LU is equals to 64 degrees. And 116 times 2 is equals to 32 plus 64 degrees, which will be equal to 296 degrees. And now the measure of arc LEU is 296 degrees. Well, the fourth theorem tells us that if two secants intersect in the interior of the circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Now down to our fourth example for the fourth theorem. So as we can observe, it's different from the first three theorems because we have here two secants that are intersecting inside the circle. So let's now talk about the application of the theorem. So the theorem states that to find the first angle, we must add the measure of arc LR, which is equal to 210, and the measure of arc CH, which is equal to 78 degrees. So 210 plus 78 degrees, which will be it's equal to 288 degrees divided by 2, and our final answer is 144 degrees. So now the measure of angle 1 is equals to 44 degrees. Then now let's find the measure of angle 2. How to find it? Just like how we find the first angle, we're also going to add the measure of arc LC and the measure of arc RH. So arc LC is equal to 48 degrees and arc RH is equal to 24 degrees. So 48 plus 24 is equal to 72 divided by 2 is equal to 36. So now we have both the measure of two angles. So how can we be so sure about our answers? So all of this must be equal to 360 degrees. And as far as I remember, in the theorems of circle, the measure of central angles will always be equal to the measure of its intercepted arcs. So if these given examples are equal to 360 degrees, then the central angles must also be equal to 360 degrees. The last, or the fifth theorem, states that if a secant and a tangent intersect at the point of tangent C, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So finally, we're down to the fifth or last theorem. So according to that theorem, a secant and a tangent must intersect at the point of tangency, which is also called the right angle because it is equal to 90 degrees, as far as I remember. And now let's talk about the application of theorem. So how do we find the angle 1 or the angle YBA? So we're going to find it by just finding the measure of arc YLB, which is already given. YLB, it's 180 degrees, and divided by 2. So 180 divided by 2 is equal to 90 degrees. So the measure of angle YBA is equal to 90 degrees. So just like what we did in this first example, we're also going to find the measure of arc YB and divide it by 2, which is also equal to 180 degrees, divide by 2, which will also be equal to 90 degrees. So this is the, I make this example as very easy because if I make it complicated, it will be hard for students like me to understand this fifth theorem. I think that's it. Thank you for listening, and I hope that you have learned and understood the 5 theorems on angles formed by tangents, secants, and chords. See you next time! Bye!